Temperature refers to the degree to which an object or system is hot or cold. That's what the molecules are. Physical quantity of thermal exercise intensity. Then you know that in the universe, how many degrees can the temperature limit reach? How many degrees can the minimum offline be reduced to? In theory, there's actually no upper limit. It can reach any height. Because in the microscopic world, temperature is measured by the intensity of particle motion. That is, the faster the particle moves, the temperature will be higher. And this movement can increase with energy. And hence, in the framework of chivalrous relativity, although there are massive examples, it is impossible to reach the speed of light. But their kinetic energy can be infinitely increased. Because when the speed of the child is infinitely approaching the speed of light, its kinetic energy will also tend to infinity. Therefore, the temperature will also tend to be infinitely high. However, in the universe, the temperature has not reached infinity. That's just the theory. The highest temperature known to man was 13.80 billion years ago, the first moment of the birth of the universe. That is, the first plunk at the beginning of the Big Bang. Temperature in time, also known as Planck temperature, scientists calculate according to the modern model of the universe. At the moment of the Big Bang, its temperature reached about 140 million quintillion degrees. At this temperature, in the beginning, all matter in the universe, atoms and elementary particles do not yet exist, and the four known fundamental forces are also unified. After being together, as the space continues to expand, temperature drop, the universe never appeared again. This high temperature, the highest temperature in the universe. Let's talk about the lower limit of temperature. Although there is no upper limit to temperature, but it has a theoretical lower bound. That's absolute zero. That's minus 273.15 degrees centigrade. But absolute zero is something we can never reach. Earlier we said, the temperature of an object is determined by the thermal motion of particles. The more intense the thermal motion of the particles, the higher the average kinetic energy. Then the temperature of the macroscopic object is higher. Conversely, when the thermal motion of the particles comes to a stop, the temperature is approaching absolute zero. And in quantum mechanics, the microscopic particles that make up everything in the universe, children have uncertainty. Its position and momentum are forever changing. And it never stops. That is to say, uncertainty stasis in quantum mechanics, absolutely static existence. If the example stops, its position and momentum will be determined. It's obvious. Violates the uncertainty principle of quantum mechanics. And according to the third law of thermodynamics, absolute zero can never be reached. Only infinitely close. Because any space has to have energy and heat. So absolute zero, we will never be able to reach.